All right. The second one is disynaptic reflex. Till now, we studied about the monosynaptic reflex, that was a stretch reflex. Okay, there was only single synapse in that entire reflex arc. In this one, the inverse stretch reflex, there are two synapses. The number of synapses are two, not only one, two synapses. Secondly, it's known as inverse stretch reflex. As the name itself suggests, when we stretch a muscle, what is the norm? Norm is that muscle should contract. But in this scenario, when we stretch the muscle, it will relax. Instead of contracting, inverse or opposite will happen. That's why it is called as inverse stretch reflex. So why this is happening? See, if we stretch a muscle, till now what we have read is, if we stretch a muscle, it will contract. If we keep on increasing the stretch, the strength of the stretch, the strength of the contraction will keep on increasing proportionately. Like we were stretching the muscle, then we were recording the strength of the muscle contraction. So, and the second scenario, along with the stretch, if we are stimulating more gamma motor neuron, that was making the muscle to contract more strongly, right? So it will keep on increasing up to a certain point. After that point, harder a muscle is stretched, stronger initially harder a muscle is stretched, stronger is the reflex contraction, but that is possible up to a certain point. However, after that point, if you keep on increasing the stretch strength, the muscle will relax instead of the contraction. And why it is happening? All the things, like who is making it to relax instead of contraction, all these things are different, altogether different. Look, receptor for this inverse stretch reflex is Golgi tendon organ, but the receptor for the stretch reflex was muscle spindle. What is Golgi tendon organ? Golgi tendon organ is, it consists of a net-like collection. It's like, say, if we look at this diagram, this one, these net-like collections are there, knobs are there, knobs. They are present in the tendon. See, this is the tendon bundle, this is the fleshy part. So one difference is the location of the sensory receptor for the inverse stretch reflex. It is present in the tendon. The stretch reflex receptor was present in fleshy part of the muscle within the belly, right? And the other difference is the name, it's Golgi tendon organ. And these Golgi tendon organs, one Golgi tendon organ is present within, it involves 5 to 25 muscle fibers, 5 to 25 muscle fiber. So from these Golgi tendon organs, these nerve fiber which are carrying the afferent impulses, they are type 1B. In the muscle spindle, it was 1A and type 2, but over here they are type 1B sensory nerve fiber. And other difference is it ends on inhibitory interneuron. Inhibitory interneuron, like say in stretch reflex, that fiber was going and synapsing with the motor neuron, alpha motor neuron. In this inverse stretch reflex, it will go, then there will be interneuron, and that interneuron will form connection with the alpha motor neuron. The same muscle we are stimulating, and same muscle these alpha motor neuron are coming. The main difference, what is the main difference? The main difference is, this is for the stretch reflex, only one synapse, and it releases glutamate neurotransmitter. But in this one, inverse stretch reflex, there are two number of the synapses, 1 and 2. These 1B fiber which are carrying the sensation, it stimulates this interneuron, and this interneuron happens to be inhibitory neurotransmitter is released, so which in response will less excite the alpha motor neuron, so it will end up in relaxing the muscle. Okay, that's why it's written like it ends on inhibitory interneuron. It leads to generation of inhibitory postsynaptic potential on the motor neuron supplying the muscle from which Golgi tendon organ arises. It also makes excitatory interconnection with the motor neuron to the antagonist. Like in the case of the stretch reflex, the antagonist muscle that was making inhibitory connection, but in this one it will make the excitatory interconnection. So, this is the again one more diagram showing the Golgi tendon organ, like these are the knobby ending net like collection of the nerve fiber that is present within the intrafusal tendon fiber. These are intrafusal and this is extrafusal, and this nerve fiber is myelinated nerve is 1B. Okay. So, see, I will give you an example. What happens, like say if you are, say how to tell you, अगर आपने कोई मसल कॉन्ट्रैक्शन हो रही है, if there is some type of the muscle contraction happening and you are providing the resistance, you will keep on providing the resistance up to a certain limit. जैसे इस आप जैसे एग्जांपल लीजिए पंजा लड़ाने का, पंजा लड़ाते हैं आपस में, तो उसमें क्या करते हैं, यू विल कीप ऑन प्रोवाइडिंग द फोर्स, कि आप किसी के साथ पंजा लड़ा रहे हो, अगर दूसरे वाले जो अपोजिट आपका है कॉम्पिटिटर, उसने रजिस्ट किया है, आपने फोर्स अप्लाई की है उसके आर्म को नीचे ले जाने के लिए और उसने रेजिस्टेंस प्रोवाइड किया है, तो वो रेजिस्टेंस प्रोवाइड करेगा, जितना ज़्यादा रेजिस्टेंस प्रोवाइड करेगा उतना ही ज़्यादा टफ होगा आपके लिए उसको ले जाना. सो इट विल कीप ऑन कंटिन्यूइंग, कि जैसे जितना ज़्यादा रेजिस्टेंस प्रोवाइड होगा उतना ही ज़्यादा आपको जोर लगाना पड़ेगा. बट एट द एंड जब आप जीतते हो तो क्या होता है, ऑल ऑफ अ सडन एकदम ढीला पड़ जाता है उसका हाथ. देखा है, नोट किया आपने? तो वो एकदम ऑल ऑफ अ सडन क्यों हुआ? क्योंकि जो उसने रेजिस्टेंस प्रोवाइड किया था मसल में, इसने स्टिमुलेट कर दिया है गोल्गी टेंडन ऑर्गन को, उसकी मसल के बहुत ज़्यादा उसने रेजिस्टेंस प्रोवाइड किया एंड गोल्गी टेंडन ऑर्गन ने रिलैक्स कर दिया उसकी मसल, तो एकदम उसका लूज हो गया है. सी ये देखिए, इस जस्ट लुक ओवर हियर. सो इन दिस एग्जांपल दिस इज द muscle and this one is, if we look at the inner diagram, this is one F fiber, it is carrying the sensation from the muscle spindle, it is forming only one synapse to the motor neuron and this is making the muscle to contact. But in the case of the inverse stretch reflex, these Golgi tendon organ, they are getting stimulated and their sensation is carried via 1B fiber. It goes and it doesn't directly end on the alpha motor neuron. It ends on the alpha motor neuron, same alpha motor neuron, via one more interneuron, that is inhibitory interneuron releasing the inhibitory mediator. So the response will be generation of IPSP in this alpha motor neuron. That's why it will get relaxed, right? That's why it will get relaxed. And one more thing about the Golgi tendon organ is, if we look at the Golgi tendon organ, say I will try to say the Golgi tendon organ, unlike the spindle, it is present in the series in the muscle fiber. Muscle spindle was, say this was the extrafusal fiber and muscle spindle was present in the intrafusal fiber, So, this interphyseal fiber is in parallel with the extraphyseal fiber. So, when these extraphyseal fiber were contracting, they were moving inward, it was making this muscle spindle to relax, right. It was making them to relax. So, they were getting stretched out when the muscle was getting stretched outwardly, but in the scenario of the Golgi tendon organ, they are present in the tendon. They are present in the tendon. Say, I will try to draw the tendon with say yellow end. Okay, yellow end. So, this Golgi tendon organ is present in these areas. Okay. So, if the muscle contract first, if the muscle stretch means we are stretching this entire muscle, this is the one connection, this is the other end. Okay. If we stretch it outward or if we contract the muscle inward, in both the scenario, what is happening to this part? If it is getting stretched out, even then they are getting stretched, right. If there is inward movement, this part is getting contracted, even then they are also getting stretched. So, we can say the Golgi tendon organ, they are present in series, they are present in series with the muscle fiber. So, they are stimulated by passive stretch as well as by active contraction of the muscle, and threshold for Golgi tendon organ is low. If the threshold for Golgi tendon organ is low, then why aren't they are getting stimulated when the muscle is passively stretched? The reason for that is because the more number of the elastic muscle fiber, not more number, more elastic fiber, these muscle fiber, instead of compared to this yellow end, the tendinous part, they are more elastic. So, passive stretch is maximally taken up by these elastic fibers. So, whether there is passive stretch or the contraction, initially it will be taken by these elastic muscle fiber. Once it crosses the limit of those elastic muscle fiber, उनकी भी अपनी limit है, once it crosses that limit, then these tendinous part will take the burden, share the burden, and they will get stretched and Golgi tendon organ will get stimulated, right. So, that is regarding the Golgi tendon organ, and it is kind of a protective mechanism, you can say. The Golgi tendon reflex, it is kind of a protective, कि आपने जितना ज़्यादा stretch किया, if you keep on stretching, keep on increasing the force of the stretching, ultimately the muscle can get torn, okay, you can tear apart until and unless there is some defense mechanism as in the form of the Golgi tendon organ. So, it acts as a protective mechanism. Okay. Then there is, like I gave you the example of that arm wrestling. In arm wrestling, the competitor of yours is providing the resistance. So, initially when you are trying to move his arm down, there will be very high resistance. That resistance will keep on increasing, and then up to certain limit it will keep on increasing, and finally the Golgi tendon organ of the competitor's muscle, arm muscle, will get stimulated and it will give away, and then all of a sudden it will be relaxed easily, it will move downward. So, have you like observed like clasp knife? Do you know the clasp knife? Clasp knife rigidity, this is called as clasp knife. जैसे आपका स्विस नाइफ होता है ना, जैसे आपका ये है, मान लो इनिशियली ये जो वुडन का बना हुआ है, एंड देन इमेजिन दिस थिंग इज नाइफ. Initially when you are moving this knife downward, up to certain there will be very resistance, and after that it will give away easily. Or take it the opposite example, say आपने इस नाइफ को बाहर की तरफ मूव किया है, तो इनिशियली रेजिस्टेंस होगा, बाद में एकदम रिलैक्स हो जाएगा. सो दिस काइंड ऑफ द रिजिडिटी इज कॉल्ड एज क्लास्प नाइफ रिजिडिटी. दैट हैपन्स in these motor neuron lesions we will talk about in the next class. Okay, just remember the clasp knife rigidity it is called. Okay. So, these are diagrams which show the same thing, say the stretch and inverse stretch. In the combined diagram, if one A fiber is stimulated, it is going and stimulating monosynaptic via the monosynapse to the alpha motor neuron, muscle is contracting. If the stretch is very severe, then one B fiber will get stimulated via the Golgi tendon organ, and it will end up on interneuron, and that interneuron happens to be inhibitory, and that inhibitory interneuron will generate IPSP in the alpha motor neuron, and it will make the muscle to relax. Okay, that is the inverse stretch reflex. The same, like this is just inverse stretch reflex, Golgi tendon organ that is present in the tendon via 1B fiber, ends up on the inhibitory interneuron, which inhibits or generates the IPSP in alpha motor neuron. Muscle tone we have covered. Now, that was the example of disynaptic reflex. Now, coming to the last one, the polysynaptic reflex, means the number of synapses are more than 2, and the perfect example of the polysynaptic reflex is withdrawal reflex. And these are few of the features of the withdrawal reflex. Either there will be just withdrawal, or there will be crossed extension along with the withdrawal, and there are certain terms like these are the keywords in this one. First and foremost is it should be strong stimuli, and that stimulus, though it is strong, it needs to be irradiated, means spread out to the neighboring synapses. Okay, so let me give you an example of this thing. In the first lecture of this motor system, I said if you are in the kitchen, right, if you are in the kitchen and preparing some food item, there will be 3 scenarios. If you touch the hot oven or any कुछ गर्म तवे को आपने टच किया है, अगर डिपेंडिंग ऑन वो कितना गर्म तवा है, हल्का सा गर्म होगा तो क्या होगा आपका रिस्पॉन्स? इमीडिएटली you will remove your hand. You will remove your hand. What is that? That response is local response, right? Local response means you are just moving your hand away from the stove. Okay, moving your hand away. So, where exactly the movement is happening? It's happening on the wrist joint. If that painful stimulus or the thermal stimulus the ज़्यादा strong है, if it is more heated, then you will not only remove your hand, you will remove entire your arm, you will withdraw entire of your arm. It means the movement is happening not only on the wrist joint, it will also happen on the elbow as well as shoulder joint. That is called as flexor response, means you are flexing your entire limb away. Okay. When a noxious stimulus is applied to the limb, typical response will be contraction of the flexor muscle. And what was happening along with the contraction of the flexor group? Extensor group were getting relaxed, so that that flexion muscle or withdrawal muscle or the flexor one, it happens smoothly. Okay. Now, the third one is crossed extensor reflex. अब आप सोचिए, जस्ट इमेजिन, ये हो जाता है कई बार कि आपने उस तवे को नॉट ओनली यू टच इट, आपको पता ही नहीं है, अनअटेंटिवली आप कहीं और ध्यान है, आपने उसको पकड़ के हटा दिया है, उस गर्म चीज़ को आपने पकड़ लिया है, हटाया, तो आप क्या करते हो? यू कीप ऑन जंपिंग ना, एकदम आप कूदते हो, तो क्या रिस्पॉन्स हो रहा है? आपने उसको छोड़ा है तवे को, हाथ को पूरा हिलाते हो, टू एंड फ्रॉम मोशन ऑफ द एंटायर लिम्ब, जैसे आपने राइट लिम्ब से, आपने राइट हैंड से हटाया है तो पूरा हाथ हिलाओगे, आप जंप करोगे, यू विल कीप ऑन जंपिंग, हॉपिंग अराउंड. दैट इज द क्रॉस्ड एक्सटेंसर रिफ्लेक्स. Crossed extensor reflex means when the strong stimulus is applied to the limb, the response not only limits up to the flexion or withdrawal of the limb, but also the extension of the opposite limb. And this extension of the opposite limb along with not only on the upper limb, it will also go up to the lower limb. Okay. And why this cross extensor reflex is happening? So that on आपने एक टांग उठाई है तो दूसरे वाली टांग की एक्सटेंशन होकर it will support the body. Like if one limb is raised off the ground, the other limb will support the body. So that is the crossed extensor reflex. So this is the severity or grading of the withdrawal reflex. Okay, this is the severity or grading of the withdrawal reflex. So there is withdrawal happening over here. See, there is withdrawal happening over here. Crossed extensor is happening. Stimuli should be strong to generate the crossed extension, and irradiation of the stimulus happens. And there is one more term, that is the reverberating circuit and prepotent or preempt. What is this prepotent and preempt? We will cover this one. Okay, see, look how this withdrawal reflex is happening. I will zoom in. Say this is the limb, जहाँ पे आपको कुछ आपने इस लिम्ब से गर्म चीज़ को आपने टच किया है. So those fibers, painful stimulus, will be carried by A delta and C fiber through the afferent limb, and what will happen? It will go up to the spinal cord level and stimulate the flexor muscle. That will make the muscle to contract, right? That will make the muscle to contract, the flexor muscle. And what is happening to the extensor group? This interneuron is releasing the inhibitory interneuron to the extensor group alpha motor neurons. So it is getting relaxed. So that's why the flexion of this limb will happen, and it will be assisted by the relaxation of the extensor group. Now this stimulus is so strong that it is not only affecting the ipsilateral limb, it is also affecting the contralateral limb, right? And how it is affecting the contralateral limb? In the contralateral limb, it is generating exactly opposite response from the ipsilateral. In the ipsilateral limb, it was making the flexor muscle to contract and extensor muscle to relax. But what is happening in the contralateral? Flexor group of the muscle is getting inhibited and extensor group is getting stimulated. How it is getting inhibited, flexor and extensor stimulated? Because the interplay of the interneuron is in such a way that this interneuron, which is providing or which is stimulating the alpha motor neuron to the contralateral flexor group, is inhibitory, and this interneuron happens to be stimulatory for the extensor group of the contralateral limb. So what is the striking feature of this entire diagram? Striking feature is there are so many number of the synapses. So that's why it is a polysynaptic reflex, and there is only one afferent fiber and it is getting irradiated. Irradiated means it is getting spread out not only to the ipsilateral limbs, flexor and extensor, it is also getting spread out to the contralateral side. And not only contralateral, if we keep on increasing the strength of this painful stimulus, more and more noxious stimulus, it will not only involve the same segment, it will also move upward as well as the downward throughout the spinal cord. That's why जैसे आपने अगर गर्म तवे को पकड़ के आपने उठा लिया है तो you will keep on jumping. For the keep on jumping, आपके all the four limbs have to react. So that irradiation has spread out not only up to the brachial plexus level, it has also gone to the lumbosacral region, right? So that's why it is called as irradiation. Now who helps in irradiation spread out of this much? Like say stimulus can be very strong, but still it is spreading out throughout the entire spinal cord. So who is helping? It is helped by this reverberating circuit. Let's take the example of this diagram. What is happening in this diagram? See, there is only one sensory neuron, okay, and in this diagram we have taken the example of 3 division of the sensory neuron, like either A pathway or the B pathway or the C pathway. Okay. So, A pathway, how many number of the interneurons are there? 2 interneurons. How many number of synapses? 3 synapses are there in the A pathway. In B pathway, the number of synapses is 1, 2, 3, 4, 5. And in C pathway, the number of synapses is 1, 2, 3, 4 and 5. Same, like B and C has 5 number of the synapses. Now, one by one, if this impulse travels via A pathway, it will reach earliest. Out of these 3 pathways, it will reach earliest via A pathway. If it takes the B pathway, it will take some more time as compared to the A. And if it takes C, what is the difference between B and C? The number of synapses is same. But what is different in the C? Different in the C is this third neuron. It is also giving one collateral to the interneuron, which in turn is giving branch, giving the feedback. And this interneuron is not Rancho cell. If it would have been Rancho cell, it would have been inhibitory. It's not inhibitory, it's excitatory. It's excitatory. So, what is the significance of the C pathway? Forget about the B and A, just imagine there is only this C pathway. You provided stimulus, painful stimulus, and just once you provided, only once you provided the stimulus, painful stimulus. If it takes only the B pathway, it will reach to this motor neuron and it will die down. But if it takes instead of the B, C pathway, it will take the same time as that of the B, but it won't die down as earlier as it was supposed to die down in the B. Why? Because see, this neuron releases the neurotransmitter, which in turn makes this neuron to release neurotransmitter. Ultimately, this entire wave of the stimulation will die down, but this branch gives interneuron and interneuron in turn stimulates its originator. जो ये स्टिमुलेट हुआ, ये डाई डाउन हो रहा था, बट डाई डाउन होने से पहले ये फीड फॉरवर्ड फैसिलिटेशन हो रही है, ये नॉट फीड फॉरवर्ड, सॉरी, फीड बैकवर्ड फैसिलिटेशन. हमने फीडबैक इनहिबिशन देखा है, दिस इज फीड फॉरवर्ड फैसिलिटेशन. It won't letting that impulse to die down, so it will prolong the impulse. That is the one reason for that crossed extensor withdrawal reflex. Second thing, first and foremost is it will spread out via so many number of the synapses, and for this first and foremost was strong stimuli. Second is so many number of the synapses. Strong stimuli will travel along so many number of the synapses. It not only go to the ipsilateral side, it will go to the contralateral side. Third, if that strong stimulus persists for a longer duration, it will not only spread to the contralateral limb, it will also spread to upward and downward of the spinal cord. And who is making that strong stimulus to last longer? This reverberating circuit. So, this is the schematic depiction of the connection between afferent and efferent neuron in spinal cord. This pathway is called as a reverberating circuit. I will give you one more example of the reverberating circuit. It's not only in the withdrawal reflex, there are so many examples of the reverberating circuit that happens within the brain and the spinal cord. Like, say, just imagine one thought. Something happened with you that maybe आप जस्ट आपके फ्रेंड के साथ आपका कुछ हो गया, अनबन हो गई, जो भी बात है, दैट कुछ इंसिडेंट है, यू विल ट्राई टू रिमूव दैट थॉट out of your mind, but you cannot. It will persist for hours and hours, right? It has happened to everybody. Who is responsible for that thought to persist for so many hours? This reverberating circuit, because this reverberating circuit or the feed back facilitation is not letting that stimulus to die down, right? And once you, like they say, just sleep over the thing, आप सो जाते हो, सुबह उठते हो भूल जाते हो वो चीज़. Why? It's kind of you have flushed this entire pathway जो reverberating हो रहा था. आप सो गए, आपके वहाँ पे रिलैक्सेशन होगी, वो रेस्टिंग कंडीशन में जो भी हुआ है न्यूरोट्रांसमीटर का, you will wake up fresh and it's kind of, you can say, there is flushing out happened over there. So that is the withdrawal reflex. And there was one more term in the withdrawal reflex in the previous slide, that is preempt, right, or prepotent. What is preempt or prepotent means? When this kind of the strong stimulus, strong noxious stimulus comes, spinal cord or the whatever the reflex is taking place, all other reflexes are also taking place. So spinal cord will forget about those reflexes and will concentrate only and only on this strong stimulus. Okay, only and only on this stimulus. So that is withdrawal or the polysynaptic reflex. Again the same scenario in the diagram, like say the flexor and all these, withdrawal reflex and the flexor opposite. Okay, so that's all.